Hello everyone, this is my first ever video and yes, I'm visibly more comfortable talking to a database than to a camera right now. I'm Panos, I'm a data engineer who somewhere along the way also became an AI engineer, which mostly means I've debugged SQL at 2 a.m. in the morning arguing with an LLM about why it thinks customer ID is a date. Also first time YouTuber and currently sweating more than the demo I just showed you. So let's get into it before I lose my nerve. Anyway, enough about me. Let's talk about why every data company suddenly cares about text to SQL. Most leading platforms include some form of text to SQL. OpenAI, for example, has natural language analytics capabilities powered by GPT models that generate SQL over connected enterprise databases. Microsoft, with Copilot, brings conversational SQL and data exploration across Microsoft Fabric, SQL Server, Azure SQL, and Power BI. Snowflake, with Cortex analysts, converts business questions into SQL using a semantic model for governed analytics. Additionally, Databricks, with Genie, enables business users to query enterprise data conversationally through AI-powered analytic spaces. Finally, Google, using Gemini and BigQuery, lets users ask questions in natural language and automatically generates SQL and analytical insights. But what exactly is text-to-SQL? How does it work? And why do most impressive demos fail the moment you connect them to a real enterprise database? In this video, I'll explain what text-to-SQL really is, how it works behind the scenes, and why building a production system is much harder than simply generating an SQL query. But let's start with the basics. Text-to-SQL is exactly what it sounds like. Instead of writing SQL yourself, you ask a question in natural language. For example, show me total revenue by region for last quarter. And just like that, AI understands your question, generates SQL, executes it against your database, and returns the results. It sounds almost magical, right? And honestly, with today's language models, generating SQL is no longer the difficult part. What the difficult part is understanding what the business actually means. Let's look at a database that's much closer to a real production system than the toy examples you usually see at most demos. This PostgreSQL database contains six business domains: e-commerce, finance, HR, inventory, support, and analytics, with more than 40 interconnected tables, more than 30 views, multiple schemas, and dozens of relationships. This is the kind of complexity where text-to-SQL systems either succeed or completely fall apart.
Let's ask something that sounds pretty easy. Who are our best customers? Sounds straightforward, right? But best customers based on total revenue, number of orders, loyalty points, VIP status, recent purchases. Our customer table already contains total spend, loyalty points, VIP status, recent purchases, and maybe other attributes. Maybe the answer is already there. Or maybe we need to calculate revenue from the orders table. Or perhaps finance has the official numbers. The AI first needs to understand what best means. That's a business problem, not an SQL problem. Let's see what it did here. It filtered for VIP customers and ranked them based on their lifetime value. But why did it do that? Because in our semantic model, we have also used customer lifetime business metric. We have added it here, and probably our query used this filter. What if we read this directly? Who are our best customers based on recent purchases? For sure, the result would be pretty different. Real companies don't have one clean database though. They have many business areas. HR, for example, wants to know which departments exceeded their salary budgets. Let's see what answer we will get. Okay, we have three of them. And why did we get a clean answer? Because we had already added a business metric over here, which has to do with salary budget variance and filtering the accounts code equal to 5200, which is the filter used in this query too. On the other hand, finance may ask which invoices are overdue or inventory asks which products should be reordered next week. Maybe some fixing at the semantic model is needed right now for the stock status value. So let's go and check here. Okay, these are wrong value mappings. So let's change to the correct one. Out of stock. This is the actual value that exists there. Also for low stock and for in stock. Okay, let's save it and try again in a new chat. And we have a winner. Finally, marketing may ask something like which campaign generated the highest return on investment. So each question touches different schemas, different tables, and different business rules. This is why production text to SQL is fundamentally different from a benchmark. And this is why semantic model generation and human review and update is probably the most important stuff here. Until recently, solving those problems required manually defining thousands of rules and mappings. LLMs, though, changed that. Modern models can understand natural language intent, infer relationships between entities, reason over database schemas, generate SQL, and explain the results in plain English. That's why text-to-SQL has finally become practical. However, even the best LLMs don't know what your business means. As we saw earlier, adding just a few semantic definitions completely changes generated SQL and produce the correct result. In this demo, Savvina doesn't read the actual data stored in the database by default. It only receives the schema metadata, which is a deliberate design choice to protect data privacy and prevent sensitive information from being exposed to the LLM. If access to sample values or actual data were permitted, much of that semantic information could be inferred automatically. But in many enterprise environments, that level of access simply isn't allowed. That's why providing business context through a semantic model remains essential for accurate text to SQL. Even after the LLM understands your question and your business context, their work isn't finished. A production grade text to SQL system has to orchestrate an entire pipeline before it can safely return an answer. It needs to understand the database schema, retrieve only the relevant tables and columns, apply the correct business definitions and semantic context, protect sensitive information, and enforce access policies, generate SQL, validate the generated query, automatically detect and correct mistakes, execute the query safely, explain both the SQL and the results to the user. Just generating SQL is only one step in the entire process. In fact, it's often the easiest part. The real challenge is giving the model the right context, validating its output, and making sure every answer is accurate, secure, and trustworthy. Imagine you want to review employee performance. What could you ask your assistant? Show employee performance. But what should we use for this purpose? Performance reviews, salary history, department KPIs, manager evaluations. The answer depends entirely on business context. Without that context, two SQL queries can both be technically correct while answering different questions. That's why semantic models are becoming one of the most important components of enterprise AI. Instead of exposing hundreds of raw tables directly to the LLM, modern systems first organize business knowledge. They describe what each table represents, what one row means, important business metrics, relationships, business terminology. Only then does model generate SQL. This dramatically improves accuracy while reducing hallucinations. So finally, Text-to-SQL isn't just another AI demo. It's changing how people interact with data. But the real challenge isn't asking the database a question. It's making sure the AI understands your business well enough to answer correctly. In the next videos, we will dive deeper into topics like schema linking, semantic models, SQL validation, and the engineering techniques that turn a research prototype into a production-ready analytics assistant. See you in the next video.